Hi everyone. Now we are going to study about the question number 60, that is all about acceleration due to gravity. Means what is acceleration due to gravity and how it varies with various parameters. That is what we need to understand. So one of the simple concept only. What is the acceleration due to gravity? First thing. See, when you consider any planet, you consider a planet of mass mp and of radius rp. Now, at any distance r, if you consider a mass m, then the gravitational force is given by gmm by r square. Now, when m moves in air, the acceleration is force by mass, that is gmp by r square. Now on the surface, that is equal to gm by r square, that is the radius. So radius of the planet. So here the thing is, when particle moves near surface, there is an acceleration due to gravitational force, that only called acceleration due to gravity, gmp by rp square. Now on the surface of earth, when you consider, so that is g on the surface of earth, gme by re square, and this value approximately 9.8 meter per second square. And same thing you can also express, mass means volume times density, where density is average density of earth. If you substitute, you will get the formula 4 by 3 pi g rho into r. So this is the formula of acceleration due to gravity on the surface of any planet. Now, the very first kind of question they can ask here is comparison. Like this is one planet of mass m1, radius r1. This is another planet of mass m2, radius r2. Now here g1 is gm1 by r1 square. Here g is gm2 by r2 square. Now g1 by g2 or g2 by g1, when you consider, it is m1 by m2 into r2 by r1 whole square. So directly proportional to mass and inversely proportional to square of the radius. That is what the relation between comparison of acceleration due to gravity on two different planets. Now, the next thing what you have to understand is how acceleration due to gravity varies with height and depth. So the very first thing is height. First thing, with height. Now you consider, see here, this is planet of mass m, radius r. Now there is one g on the surface, that is gm by r square. Now at some height from the surface, there is some acceleration due to gravity, that is gm by r square, where small r is distance from the center, that is r plus h whole square. Now if you divide both of them, gh by g on the surface equal to r square by r plus h whole square, or else r plus h by r whole power minus 2. I took numerator to denominator, denominator to numerator, so that you will get one general formula. So g at any height equal to g on the surface into r square by r plus h whole square. This is the formula. Now, when you consider when h is very much less than r, so g at any height equal to, see, use this formula 1 plus h by r whole power minus 2. And as h is very much lesser, and this formula will become approximately 1 minus 2h by r according to binomial approximation. That is, what is that binomial approximation is 1 plus x whole power minus n equal to y minus nx when x is very much less than 1. Like here h by r is very much less than 1. So this is the variation in acceleration due to gravity with height. Similarly, with depth you consider. Now you consider this is the planet, maybe Earth or any other. But usually they will ask question based on Earth. So this is on the surface, that is gm by r square. But I will take the formula in terms of average density 4 by 3 pi g rho into re, where r is the distance of the point from the center. Now you consider at any depth d. Now the distance is r, that r equal to re minus d. So that at this point the acceleration due to gravity will become 4 by 3 pi g rho into r minus d will come. Why I am taking the formula in terms of density? Because when you consider inside point, only the effective mass you have to consider. Not all the mass will affect that point. So that's why we will take the equation in terms of density, so that average density is same for everything. You take portion of mass or full earth you consider. So the density remains same. That's why we have taken formula in terms of average density. Then if you divide GD by GE, then it will become R minus D by R. Then G at any depth will become G into 1 minus D by RE. Now if the condition is given, like if at particular height and at particular depth G is same, that means G into 1 minus 2h by r equal to G into 1 minus d by r. Then the condition will become d equal to 2h. Like that they will ask questions based on how the acceleration due to gravity varies with height and depth, nothing but altitude. Now similar way, what is the variation in acceleration due to gravity with latitude also they will ask sometimes. That is, see here, when you consider this is the axis of rotation of the earth. Now at any latitude when you consider at an angle lambda, then see here there is one centrifugal force will act on the body. Like that particle you consider as m, the planet mass is m. Now there is one centrifugal force in this direction, because the body will move in a circular path like this. So as the body is moving in a circular path in horizontal plane, there is one centrifugal force will act. So the centrifugal force is mass into acceleration due to gravity. Wait. The centrifugal force general formula is mv square by r or else mr omega square. Now you will take the components one along this and one along this. Now already here gravitational force mg is acting. Now due to rotation, the effective weight will become this minus this, the component. Let's take like so the component of this along this one when we consider. Here one small correction. This is not latitude, this is latitude. With equator we have to consider. So that here this angle also will become lambda. So that this will become mr omega square cos lambda, where this is the radius. Now if you consider here triangle, see like this is small r, this is capital R, and this is height. Now this angle is lambda, then r will become r cos lambda. So that the effective force, that is mg dash, will become mg minus mr omega square cos square lambda, but small r is capital R lambda. So that mr omega square cos square lambda, so that g dash will become g minus r omega square cos square lambda. So this is the variation in g with respect to altitude. Sorry, latitude. So here you just correct it. It is not altitude, it is latitude. Altitude means height and depth. So this should be latitude. Now, based on these things, means what is the acceleration due to gravity and how it varies, and how can we compare acceleration due to gravity between two planets, and what is its dependence on height and depth as well as latitude. So based on this, how the questions will come. Let's see. Now the very first question is the acceleration due to gravity at the moon's surface is. So now you consider moon. This is moon. Now on the surface of moon means g into mass of moon by square of the radius of moon. Now they have given mass of moon. Mass of the moon we have to find out. And acceleration due to gravity on the moon is, this is for moon, how much? 1.67 meter per second square. And radius is 1.74 into 10 power 6 meter. Then mass formula, mass value they are asking, that is g on the moon into r square by capital G. So 1.67 into r square means 1.74 into 1.74 into 10 power 12 by capital G means 6.67 into 10 power minus 11. So this way they can ask the question directly based on the formula. What is the acceleration due to gravity for a particular planet or subplanet, anything. So they will give the required data. You need to be careful about calculation. Fast and perfect calculation is needed. Now, as I said, the comparison based question. Assume that if the earth were made of lead of relative density 11.3, then what would be the value of acceleration due to gravity on the earth's surface? Now the relative density of that they have given as 11.3. So that here what you have to do is you have to take the formula in terms of density. Now the very first thing is you have to find the density. So how can you find the density from relative density? Relative density means density by density of water. So that it will become 11.3 kg per meter cube, because density of water is 1 kg, not 1,000, 10 power 3 kg per meter cube. So that here into 10 power 3 will come. This is the density of the now earth will become. Now G value is gm by r square, but that is also equal to 4 by 3 pi g rho into r. So 4 by 3 pi g, everything is constant, and density is 11.3 into 10 power 3 kg per meter cube, and radius is 6,400 kilometers, or else 6,400 into 10 power 3 meter. So now all values are there. You can substitute and you can calculate. But again, the calculation. So the question based on formula means there you need to take care of fast and perfect calculation always. Now we'll see next question. What will be the relation between the acceleration due to gravity on the surface of the earth and on a planet respectively? whose mass and radius are 4 times that of Earth. Now one is Earth, mass is ME, radius is RE. Another is one planet. Let's take mass is MP, radius is RP. Now whose mass is, so mass of planet is 4 times that of Earth and radius of planet is also 4 times that of radius of Earth. Then G on planet by G on Earth equal to M planet by M Earth into R Earth by R planet whole square. So that M planet is 4 times mass of Earth times R Earth by R planet is also 4 times whole square. So cancel. Then you will get 4 into 1 by 4 square, nothing but 1 by 4. So what is the relation will become? G on Earth is 4 times G on planet. This way you can get the questions based on the comparison between two different planets. Now the next question is, at what altitude the acceleration due to gravity reduces to 1/4 of its value? G at any height is G into R by R plus H whole square actually. Now here the G at any height will become G by 4, 1/4 of its. So that G into R by R plus H whole square. So G cancel, 1 by 4 equal to R by R plus H whole square. If you remove square, then you will get R by R plus H, 1 by 2 equal to. If you cross multiply it, then R plus H equal to 2R, then H equal to 2R minus R, that is R. So at a height of capital R equal to the radius, then the acceleration due to gravity value becomes 1/4. When G value changes very less, then only you have to take that H less than R condition. Otherwise, you have to take this condition only. So when H is very lesser, then G also changes very small amount. In that case only you have to use that G at any height H equal to G into 1 minus 2H by R formula. Now, one last and final question. Calculate the angular speed of rotation of the Earth so that the apparent G at the equator becomes half of its value at the surface. So G at any latitude, G lambda equal to G minus R omega square cos square lambda. Now at equator, the lambda value is 0 degrees. Now at poles, the lambda value is 90 degrees. Now at equator they are asking so that it will become G minus R omega square. Now calculate the angular speed of the Earth so that apparent G at equator becomes half of its value at the surface. That means G at equator should become half, G by 2. So G by 2 equal to G minus R omega square. So that here R omega square will become G minus G by 2, G by 2. So omega square equal to G by 2R. Now omega equal to under root G by 2R. Now the time period got changed. See, let's take the new angular speed is like omega dash, this one. Now initial angular speed, if you consider omega, that omega equal to what it will become? Root G by R. Or else you can take directly, so time period equal to 2 pi by omega. So 2 pi root of R by G. Now the new time period equal to 2 pi by omega dash. So 2 pi by omega dash is root of G by 2R. That means T dash will become root 2 times initial time period. So the time period got increased to root 2 times. So that here time period got increased means the length of the day also changes. So time period nothing but what? Time taken to complete one revolution. So now the question is, calculate the angular speed of rotation of the earth so that the apparent g at the equator becomes half of its value at the surface. So what is the g at any latitude lambda? G minus r omega square cos square lambda. Now at equator, the value is lambda 0 and at poles, the lambda is 90 degrees. They are asking at equator. So at equator means G at equator means G minus R omega square cos square 0. So GE will become G minus R omega square. Now G at equator should become G by 4 such that omega value should be adjusted. That means G by equator becomes half. Sorry, not 1/4. It should become half. So G by 2 minus G by 2 equal to G minus R omega square. So R omega square will become then G by 2. Then omega will become root of G by 2R. So that the new time period of the earth will become now 2 pi by omega. It is nothing but 2 pi root of 2r by g, where r value we know that 6400 kilometers and g value is 9.8. Then you will get t dash value. So if you substitute and if you calculate, it will come approximately 2 hours. So this is the time period means what? Time taken to complete one revolution. That is nothing but what? Length of the day. Actual length of the day is what? 24 hours. But here it is 2 hours because of the change in speed. So it is rotating very fast, very quick. So that's why the time period got decreased. So that is what you need to understand here. So now the new length of the day according to this question is 2 hours. So like that, similar questions I have given as assignment questions. So please just try to understand and try to solve them so that you will get the idea what kind of questions will be asked based on acceleration due to gravity. What is acceleration due to gravity and how you can compare between two planets, how it changes with various parameters. So thank you all of you. Will continue in the next session with the next question. Thank you.